first grade teachers. We're here today to work on a problem that goes along with our IOA 2.A and 2.C. 2.A talks to us about solving addition and subtraction problems within 20 using a variety of strategies. 2C tells us that we need to recognize and use the inverse relationship between subtraction and addition within 20 to solve authentic problems. So let's take a look at the problem that we were given today. I'm going to read it. The wheel shop sells bicycles and go-karts. Each bicycle has only one seat, and each go-kart has only one seat. There are a total of 7 seats and 18 wheels in the shop. How many are bicycles and how many are go-karts? Use pictures, words, and numbers to show your math thinking. Well, there's a couple of things happening in this problem. The first thing that I want to do is I want to go back and realize that we're talking about a wheel shop, a shop that you can go and apparently buy wheels. They sell bicycles and go-karts. So before I do any mathematics, I wanted to make sure that I showed you a picture of both of these items. Most of you know what a bicycle is. Many of you have them at home. Most bicycles have 2 wheels. But I wasn't sure if you knew what a go-kart was. A go-kart is a motorized little vehicle that has 1, 2, 3, 4 wheels. They have an engine in the back, so when you push your pedal, it makes you go forward and you can turn with your steering wheel. But I wanted to make sure that you all knew what a bicycle was and a go-kart. That will help you with your math thinking for today. So let's go back to the problem now that we know what our words mean. Let's stick that right over there to help you remember if you need to. Okay? And again, the go-kart has 4 wheels. Okay, so each bicycle has only one seat, and each go-kart has only one seat. There are a total of 7 seats. 7 seats. And there's 18 wheels in the shop. We have to figure out how many are bicycles in the shop and how many are go-karts. So I think I'm going to use my manipulatives to help me think about that. I'm going to use my snap cubes to represent the 7 seats. I know I have to have 7 different seats in the wheel shop. It's 4, 5. Scooch the other colors up. My picture. And I have 6 and 7. 1, 2, 3, 4, 5, 6, 7. Good mathematicians double check their work because I thought I had 7, but I wanted to double check. Now I know that I have enough seats that are found in the wheel shop. But now I have to figure out those 18 wheels. So I'm going to use my 2-sided counters only because they're round and most wheels are round. So that's the reason I chose these. I'm going to count out 18 to make sure I have enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have 18 wheels. I'm going to have to put these 18 wheels at each of the seats to see how many are bicycles and how many are go-karts. Well, I think this go-kart's pretty cool. So I'm going to go ahead and take my 18 wheels and I'm going to take away 4 wheels. So if I have 18, take away 4, I'll put them around my seat. I do 18 take away 4, I can see 5, 10, 11, 12, 13, 14. Okay. So I have 14 wheels left that I need to put around my different seats. I think this time I'm going to want to go ahead. And so I have 14 left. I'm thinking about, let's go ahead and take 2 and make them a bicycle. Now, teachers, your students are going to approach this in many different ways. The whole idea is really to start thinking about those mathematical facts and thinking about what has happened. So before I had 14, and now I've taken away 2. 14 take away 2 leaves me with 10, 11, 12. Okay. I could also say I started with 18 and I've taken away 4 and 2, which is 6. So 18 take away 6 is left with 12. So lots of different ways, but let's see how this actually plays out. I think because this is still super cool, I want to make another go-kart. So I'm going to take 4. I'm going to take 4. I really like this go-kart. So I think I'm going to make another one. I'm going to take 4 wheels and put them around the seat to show that I have another go-kart. So I started with 12 and I've just taken away 4. Now I have 8 left. Wondering what I should do. Let's go ahead and make another bike. Okay, so let's make this one a bike. So I had 8 and I've taken away 2. That means I have 6 left. 8 take away 2 is 6. I'm thinking I want to do another bicycle. Okay, so I'm going to take 2. I had to, and put them around my seat. I had 6. Take away 2 is 4. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 wheels I've already used, plus the 4 more that's remaining, and I have 18. So teachers, as you can see, I'm trying to use as much math talk as possible in thinking about the different strategies that I might be able to use. Well, I still like that go-kart. I really do. So I'm going to put another 4 wheels to make the go-kart. Oh no, 4 take away 4 is 0, but I still have a seat left. This seat still needs wheels. So what am I going to do? I see 4 wheels on this seat, so I suppose I'm going to have to take away 2 so that this seat has its own and he can't be a go-kart. So now you can see that I've used up all of my counters and I have 4 and 4, which is 8. 4 wheels plus 4 wheels equals 8. I have 2 wheels plus 2 wheels plus 2 wheels plus 2 wheels plus 2 more wheels. So 2 plus 2 plus 2 plus 2 plus 2 equals 10. So my 8 for the golf cart and my 10 from the bicycles gives me 18 wheels. So I know I did it correctly, but how many are bicycles and how many are go-karts? So I can answer that with there are 1, 2, 3, 4, 5 bicycles and 1, 2 go-karts. Now, depending on where your students are in this process of being able to solve addition and subtraction problems within 20 using a variety of strategies. I obviously was showing at the abstract level, I was still using my concrete manipulatives and I was putting them around, but I was doing my math in my head. So if you have students that are still at the beginning of that phase, you might want them to write out every single time. So when I first made this one, I did 18, take away 4, and then students can tell you which strategy they're going to use. So some kids might go ahead and build out theirs like I did. I had them in rows of 5 so I could quickly see the 15, 16, 17, 18. And when I took away 4, I was able to see the 14. And you can have them do it that way if that's what you're working on. If you're working on with those students addition, having them find the ones that are the same and being able to add them together, or they could be all listed together and they could see doubles. 4 and 4 is 8, or they could see that this is 4 and this is 4, and that's another 4 and 4 is 8. So we have 8 and another 8 and 2 more. I know that 8 and 2 is 10, plus the 8 more is 18. So lots of different ways. I would have lots of conversation with my students, asking them how they determined these and what they knew about the numbers as they were occurring. Hopefully you have a chance to use this in your classroom. It's lots of fun. I always love starting with some inquiry where kids don't have to automatically start thinking this way, that you can automatically start manipulating those counters and putting them around, and then students start seeing that math that occurs. Have a great day, and thank you for watching.